Previously, we have seen standard integrals. Now, let's see how we can generalize them. So, let's take it one by one. Integral of f of x dx is equal to capital F of x plus c. Now, the general form would be integral of f of ax plus b dx equal to 1 by a times capital F of ax plus b plus c. Since we are saying that this is a general form, how do we get back this f of x from here? We get it if a is equal to 1 and b is equal to 0. We get integral of f of x dx equal to capital F of x plus c, where a is not equal to 0. Because if a is equal to 0, x also disappears. We don't want that. So let's verify this. Let y is equal to the result of the integration. 1 by 8 times capital F of ax plus b plus c. Differentiating it, we get dy by dx is equal to 1 by 8 times capital F prime of ax plus b times the derivative of ax plus b, which is a. A cancels out, and we have dy by dx equal to capital F prime of ax plus b. But we know that capital F prime of ax plus b is nothing but f of ax plus b. Since differentiating capital F gives us f. Let's look at the second one. Remember the standard integral of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus c. So general form would be what? Integral of ax plus b to the power of n dx. And that would be equal to 1 by 8 times 8x plus b to the power of n plus 1 by n plus 1. Again, let's verify that. We start with y is equal to the right hand side and we differentiate. Dy by dx equal to 1 by a constant times differentiating the numerator gives us n plus 1 times ax plus b to the power of n plus 1 minus 1. And denominator is a constant n plus 1, so we'll leave it as it is. But then we also have to take the derivative of ax plus b, so times a. Simplifying that, what happens? A and a cancels out, n plus 1 cancels out, and we are left with dy by dx is equal to ax plus b to the power of n. Integral of 1 by x dx is equal to natural log of x plus c. The general form of that would be integral of 1 by ax plus b dx is equal to 1 by 8 times natural log of ax plus b. So let's verify that. Let y is equal to 1 by 8 times natural log of ax plus b. Dy by dx is equal to 1 by a constant, times the derivative of natural log, which is 1 by ax plus b, times the derivative of ax plus b, which is a. A cancels, and we have dy by dx equal to 1 by ax plus b, which is there under the integral. Let's look at the next one. Integral of e to the power of x dx is equal to e to the power of x plus c. This is what we saw previously. Now the general form would be integral of e to the power of ax plus b dx. And that is equal to 1 by 8 times e to the power of ax plus b. Again, let's verify. Y is equal to 1 by 8 times e to the power of ax plus b. So differentiating it, dy by dx is equal to 1 by a times e to the power of ax plus b times the derivative of ax plus b, which is a. So dy by dx is equal to e to the power of ax plus b, which is what is there under the integral. Let's look at the fifth one. Integral of sine x dx is equal to minus cos x plus c. This was what we had seen previously. The general form would be integral of sine of ax plus b dx is equal to minus 1 by a times cos ax plus b plus c. So again, let's verify it. Y is equal to the right hand side. Differentiating it, we get dy by dx is equal to minus 1 by a is a constant, so leave it as it is. The derivative of cos ax plus b is minus sine ax plus b. And then derivative of ax plus b, which is a. A cancels out. Minus times minus is plus. So which means dy by dx is equal to sine ax plus b, which is what is there under the integral. And finally, integral of sec x tan x dx is equal to sec x plus c. So again, general form would be integral of sec ax plus b tan ax plus b dx. And this would be equal to 1 by a sec ax plus b plus c. So again, let's verify. Y is equal to the right hand side. Differentiating it, we get dy by dx is equal to 1 by a constant, times the derivative of sec x or sec is sec and tan, sec times tan. So we have sec ax plus b times tan ax plus b, and then finally the derivative of ax plus b, which is a. So when we simplify it, this a and a get cancelled out, and we are left with dy by dx is equal to sec ax plus b tan ax plus b, which is what is there under the integral. So that was the generalized standard integrals. Of course, only some of them. And as you have noticed, pretty straightforward to address the rest of the standard integrals as well. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.